Experiencing unknown EMI issues in a VFD setup? Ferrite rings are a cost-effective and simple solution to add to the output of a VFD to reduce those issues. By their design, VFDs are an inherently noisy component. To find out why this is, let's take a look at some of the components inside of a VFD. First, we have the rectifier circuit. This takes in AC voltage and rectifies it up to DC. These diodes draw current at separate intervals, which causes irregular current draw. This leads to high harmonics here. And let's also look at the output of the VFD. Here are IGBTs. These are switches that switch on hundreds of volts, thousands of times per second. This causes high dV/dt at the output, leading to high electrical noise. EMI is addressed through electromagnetic compatibility, or EMC. Good EMC design is always the first defense against EMI. Here, this includes high-quality cables with good shielding and high strand count, as well as good cable routing. But this isn't always enough to address EMI issues. Sometimes there will just be inherent vulnerabilities in the system. Here, we can add a cost-effective and simple solution like ferrite rings. Ferrite rings act like common mode chokes and can be added to the output of the drive at the UVW or to low voltage signals like encoder cables. An alternative would be more costly solutions like sine filters or motor chokes. It's easy to see that ferrite rings achieve relatively high effectiveness at a fraction of the cost. To add ferrite rings to the drive output, we would slide a ferrite ring over the UVW phases of the motor cable. We would slide this ferrite ring on, and then we would loop it through at least once. This will typically achieve good effectiveness, but if this doesn't resolve the issue, you can always loop the cables around at least one more time. This being such a cost-effective solution, it's easy to add these early on when experiencing issues to see if they address the problem. If you have any more questions, feel free to reach out to a KEB applications engineer to learn more.